evening. My name is John Bratz with Team Omniscient, and we're glad to be able to present to you all the progress that we've made over the last 10 weeks. When our sponsor, the Air Force Tactical Exploitation of National Capabilities, or AF10CAP, approached us with the problem of Air Force imagery analysts lacking the time and manpower to review imagery coming from UAVs and satellite imagery on a day-to-day basis, we thought that we could provide value by helping analysts look for objects and anomalies of interest, essentially looking for needles in haystacks. Our main priority was to talk to as many of these analysts as we could and find what those needles actually look like and what it means for an image to actually be interesting and exploitable. And ideally, we could get our hands on imagery and actually see what analysts were looking at and ideally build a solution. So we set out to interview Air Force analysts, but also Army imagery analysts, analysts at the National Geospatial Intelligence Agency, National Reconnaissance Organizations, as well as groups tackling similar problem statements. For example, at the Joint Artificial Intelligence Center, Air Force Research Lab, and IARPA. So with our combined team background in computer vision research and background in the military, we felt that we had our work cut out for us. So during those first couple of weeks of beneficiary discovery interviews, we felt a bit overwhelmed at first, since it seemed like everyone was tackling a different problem, detecting changes in imagery to looking for missiles, identifying and tracking vehicles and video. And on top of that, there are far more types of imagery than we initially thought. So we had all of these pathways that we might go down and felt overwhelmed. We also had a crisis around at the end of week 2. We actually started with 5 team members who had the perfect background to work on this kind of problem. However, at the end of week 2, we moved from 5 group members to 2. Unfortunately, 2 had to drop due to scheduling and family issues. So by the end of week 2, we definitely could have been feeling better than we did.
Hey, John,
yeah.
This is Steve. I'm sorry. I think the video dropped out when you were describing your first slide. So can you go back and just give everybody context? Because I think it was really important, and I think it was the video.
Yeah. Can you see the slide right now?
No, your first slide.
Okay.
All the way in the beginning. Yeah, I think somehow your video dropped out. Why don't you explain the slide? I'm sorry, it just got dropped out when you were talking.
Sure. Yes, so our problem sponsor was the U.S. Air Force Tactical Exploitation of National Capabilities. The original problem was Air Force imagery analysts need an automated way to review a large quantity of collected imaging data to surface actionable intelligence to leadership, since 90+% of images are never reviewed. Is that okay?
Yeah, and then the problem as is today, I'm sorry, it keeps dropping out.
Oh, yes. And analysts lack computer vision tools to augment their ability to rapidly locate, identify, and analyze objects of interest, which would allow them to focus their time on higher order analysis tasks. We conducted 108 interviews.
Perfect, thank you. I'm sorry, that just got dropped out on my video.
I see, sorry, that might be my internet. In any case, so through our customer or beneficiary discovery interviews, we found that Air Force analysts were shifting from just identifying objects and images, like where is the green truck, to higher level understanding. So what is this green truck doing? What is its purpose? And through our discovery interviews, we found that if we could not just identify an object of interest, but say this green truck was here and it's a missile loader, and I can tell that from the context of what it's done in the past, then that would unleash analytic horsepower. So that was encouraging. And while in parallel trying to scope down a discrete, specific object and activity to identify, we were scoping out existing pilot programs and research efforts along these same lines, and identified several programs that were in the demo stage, but no automated image analysis tools that were in the hands of users. So it turns out, to our surprise, that there are currently not, we couldn't find any wheels that currently exist that we might be inventing. So we continued on presenting our first MVP of a generic computer vision tool, processing imagery as it comes into analyst systems, flagging objects and activities of interest. What those objects and activities of interest are was what we were trying to get to the bottom of. And some of the feedback that we heard was that they've heard this pitch a dozen times, and all of those demos and pilot programs bit off more than they could chew. They never rounded up with a tool that could get in the hands of a user. What users care about is less about innovation and solving every problem, and more about integration and deployment. So we thought we found an idea that we could execute on and deliver in the hands of a user when we talk to pilot operators for UAVs. However, basically solving a bandwidth and latency issue of moving images from UAVs down to analysts on the ground faster than they currently can using computer vision algorithms to prioritize images. However, we realized that we pivoted too early, deviated from beneficiary insights, and were invalidated with further interviews. So by the end of week 4, we unfortunately still hadn't found the ideal problem and object to look for in images. And so we were feeling demoralized until we found our breakthrough problem.
Yeah, and at that point, we found a breakthrough when we discovered the North Korean AN-2 Colt biplane. And while this plane may look obsolete, it's widely believed to be a critical part of North Korea's plans to invade South Korea. Analysts assess that North Korea would likely use these aircraft to drop paratroopers behind US and South Korean lines during an invasion and utilize its ability to land on patches of open ground that are as small as a golf course's fairway. And while the AN-2 Colt is an interesting initial use case, it's primarily a proxy to demonstrate what we can do with computer vision and unclassified commercial imagery. This aircraft is very visually distinctive, and thus a pretty good candidate for computer vision algorithms to detect, and it has tactical, operational, and strategic relevance. So our initial thinking going to this project is if you can detect and track this aircraft from day to day, that would provide a lot of value for the end user. And now if you could track this aircraft reliably, you could expand it, tracking other aircraft and equipment of interest. And while this problem was challenging, we thought with this discrete use case, we had a pretty good starting point to sink our teeth into the problem. And one of the challenges we encountered was that training an algorithm to detect this type of aircraft would require a lot of high resolution data, and we weren't able to get access to classified military imagery. However, we found through our interviews that commercial satellite data, like what's in Google Earth, is actually sufficient to recognize these aircraft. So we were able to compile our own data set of freely available commercial imagery for free. And at this point, we were able to outline our first MVP that was validated by end users. This was for an unclassified imagery analysis tool that uses commercial satellite imagery to detect aircraft of interest and generate outputs to integrate with the existing analyst tools. And at this point, we were also anticipating having to design our own user interface and our own integration path. We were hoping to leverage my prior experience in the military to find a convenient integration path that leveraged existing cross-domain portals to move our data from unclassified networks up to classified SIPRNet. And at this point, with this use case identified, we were finally able to articulate kind of a specific value proposition to the end user, focus on the appropriate end users who would be using this tool, likely on the Korean Peninsula, and outline a specific integration pathway. Now, with all this ahead of us, in this specific application and a good set of positive user feedback, we feel like we finally hit escape velocity.
Yeah, so we're finally making real progress and we couldn't be feeling better. With additional interviews, we realized that we could get in the hands of users much faster by building everything initially with only unclassified tools. With our enhanced MVP, we will develop our algorithms with unclassified satellite imagery to identify AN2s and also be able to detect changes by comparing to a historical baseline. We'd output our detections into a KML file, which could then be uploaded to the analyst classified network. Our files would seamlessly integrate with the existing tools and workflow of analysts, enabling them to rapidly generate insights and surface actionable intelligence faster. This strategy enables us to both build technology that works and that will deliver real value by actually getting onto government systems. Right now, we're developing our machine learning models on our initial data set with our unclassified MVP in mind. We've also identified a partnership with L3Harris, in which they have a data integration platform that could, significantly decrease the time it takes for us to get onto government systems. And we're working with them on that as well. We have an unofficial demo scheduled with Air Combat Command in 3 weeks, and they're very excited to see what we'll accomplish with just 4 weeks of technology development. We also hope to continue our efforts with the endorsement of our problem sponsor, AF10CAP. Needless to say, we're feeling very optimistic about the future, and we could use your help. We're working on our next 100 interviews and want to learn more about how we could help other organizations and beneficiaries in the military, so we can identify where we go next after the AN2. We're also interested in other potential collaboration opportunities with other prime contractors. We're continuing Omniscient over the summer with John working full-time, and we'll be focused on developing our computer vision algorithms and exploring dual-use opportunities. We plan to have the support of H4X Labs and apply for AFWorks funding in late October. We're also seeking venture funding to enable us to hopefully grow and expand rapidly. If you're willing to talk to us, please shoot us an email. And thanks so much, everyone. This has truly been an amazing experience.
All right. Thank you, team. applause